In this video, I'm going to build a project with a 7-segment display in which a push button switch can generate a pulse and can increment the decimal numbers on the display. Let's connect pin 8, 2 and pin 15 of the IC to ground. Connect pin 3 and pin 16 of the IC to power. Connect pin 10 to segment A. Pin 12 to segment B. Pin 13 to segment C. Pin 9 to segment D. Pin 11 to segment E. Pin 6 to segment F. And finally pin 7 to segment G. Connect 330 ohm resistor to the common cathode pin of the display and to the ground. Connect the 1 kilo ohm resistor to the first pin of the IC and to a blank spot on breadboard. Connect the anode of the LED, longer leg, to the resistor and the other side to the ground. Now let's connect the push button switch. One side of the push button switch is going to be connected to the positive rail of the breadboard. Connect the other side of the push button switch to the clock pin of the IC, which is pin 1. And let's connect the rails of the breadboard to each other. Positive terminal to the positive and negative terminal to the negative rail of the breadboard. Let's connect the power supply to the breadboard. I have 5 volts coming into the circuit. We are getting a 0 on the display for the beginning. Whenever I press the push button switch, the decimal numbers are going to be incremented on the display, and the LED is here to indicate the pulse generator. So let's test it. So as you see, the circuit works perfectly. I hope you guys enjoyed the video. If you enjoyed it, please give me a like and do not forget to subscribe my channel. Let's connect our timer IC to the breadboard. Connect pin 4 and pin 8 of the IC to the positive rail of the breadboard. And here is pin 8. Pin 1 has to be connected to ground. Connect pin 2 and 6 of the IC to each other. Let's connect the 100 microfarad capacitor with anode connecting to the second pin of the IC and cathode to the ground. Now let's extend our third pin and the 7th pin. connect the 1 kilo ohm resistor to the power and to the pin 7 of the IC. Let's connect our potentiometer. The VCC pin of the potentiometer is going to be connected to the pin 7. And let's connect the middle pin of the potentiometer to the pin 2 of the IC. Perfect. Now let's connect the anode of the LED to the third pin of the IC, and the cathode is going to be connected to the ground using a 330 ohm current limiting resistor. Let's connect the rails of the breadboard to each other. So let's connect the power supply. I have 5 volts coming to the circuit. So there might be a problem with the wiring. Here I've connected the resistor to the 6th pin of the IC. Now let's test once more. So as you can see, the LED flasher circuit works successfully. Now I'm going to disconnect the power supply. I'm going to continue with the 7-segment display, which is common cathode, and 4026 IC. Connect pin 8, pin 2 and pin 15 of the 4026 IC to the ground. And here is the 15 pin. And I'm going to connect pin 16 to positive rail of the breadboard, as well as pin 3. Connect the 330 ohm resistor to the common cathode pin of the display and to ground. And now let's connect the IC to the 7-segment display. Pin 9 is going to be connected to segment B. Pin 10 to segment A. Pin 11 to segment E. Pin 12 to segment B, which is going to be here. Pin 13 to segment C. Then we have pin 6, which is going to be connected to to segment F. And the last one, segment G, is going to be connected to pin 7, which is over here. So I will make some space over here. Now that's good. Let's zoom out a little bit. Finally, we are going to connect the output pin of the 555 timer IC, which is over here, to the clock pin of the 4026 IC. We are done with the setup of the project. Now let's connect our power supply. As you see, the 7-segment display counter works successfully. The 555 timer IC generates a pulse which can increment the decimal numbers on the display, since it is connected to the clock pin of the 4026 IC. By changing the potentiometer, we can change the flashing rate of the LED. We can make them faster, so that on the display the numbers would change faster. If you enjoyed this video, please give me a like and do not forget to subscribe my YouTube channel. Thanks and have a good day. In this video, I'm going to show you how to test your 7-segment display, whether it is common anode or cathode, and whether the segments are working or no. So for the beginning, we have a 7-segment display. I'm not sure whether it is common anode or cathode. Let's connect a 220 ohm resistor to limit the current across the display. I'm gonna connect it to the pin 3, which is the common pin, and we hope that the 7-second display is common anode. Therefore, I'm gonna connect the pin 3 to the positive rail of the breadboard. On the other hand, I'm gonna connect the jumper wire to the ground. Let's power the circuit with 5 volts. 5 volts would be enough for this project. And via this jumper wire, I'm gonna test each segment, and if one of the segments glow up, it means that the 7-second display is common anode. So let's see. As you can see, we have a common anode. I'm not gonna connect it to the pin 8 since I will short it. Pin 7 working. This pin is not working. Segment B, the 7-second display is damaged. This segment is also not working. I think segment C. The other segments look fine. So that was it with the common anode. Let's check common cathode. I'm using another 7-second display. This time I'm gonna connect the common pin of the display to ground. We hope that the 7-second display is common cathode. Therefore, pin 3 is going to be connected to ground. And the jumper wire now has to be connected to the positive rail of the breadboard. Let's connect our power supply, positive to positive and negative to negative. And like before, we're going to test each segment. As you can see, the 7-second display, the segments are glowing up. It means that we have a common cathode in this case. Let's check the other segments. Working. Yes, that 7-second display is fine. All of the segments are working. That was it. That was a short video on how to test your 7-second display. Thanks and have a good day.